The next programme this afternoon is Near and Far, which follows in 1 minute.
You have to be fit if you're going to live in a place like this. All these hills, I'm not used to them. Still, there's one advantage of walking up a hill. You often get a good view. I'm right in the middle of Bristol here, and from this spot, I can see quite a lot of the city. Do you see the tall tower block? That one over there? I'm almost on a level with it. But I can get an even better view if I walk to the top of this hill. This is the first time I've visited Bristol, so I thought I'd better buy myself a map to help me find my way around. Let's have a look. This is where I am, in the tower on Brandon Hill. Now, this map's very useful because it shows me where all the streets are. And also it shows the parks, and it shows the main buildings in the city, like the university. There it is, over there. It's the building with the tall tower. But what this map doesn't show is that there are any hills in Bristol, and I've just discovered quite a few. If you take that little street down there, for instance, you can see it's on a slope because the houses go down in steps. But that slope isn't shown on the map. In fact, it's quite a problem showing slopes on a map because, after all, it's flat. So how can you show slopes, valleys, hills, mountains even, on a flat piece of paper? How would you do it? We asked some children how they would show slopes and hills on their own maps. Some decided to do maps of streets they knew well. Others made maps of imaginary places.
I put these arrows going upwards because that means uphill, and I put the H for hill, stands for hill. I put little lines across the road to show that it was a hill.
I've marked out grey for the road, and I've marked out green for the hills. This road is going through the green hills on my map.
I coloured the roads on my map 2 different colours, red and yellow. That was because I made a colour key. Yellow was flatland and red was hills. White Hill is a hill. Wargrave Road is flatland.
Some children showed hills as they would if they were doing a painting. This could be a painting of mountains, but these mountains are actually on a map. It's a map of a country called Narnia. You won't find Narnia in an atlas. It's a country that was invented for a story. This is another map of an imaginary country. It's got rivers and roads, and there's no mistaking where the mountains are. The easiest way of showing mountains on a map is simply to draw or paint them in, just as if you're seeing them from the side. That's what map makers did 400 years ago to show hilly or mountainous areas, like North Wales. But maps like this one show us what the land looks like from the air. Can you tell where the hills are? This map uses lots of little lines to build up a picture of the mountain slopes. The darkest patches show where the steepest slopes are. Switzerland has lots of mountains, and maps today show very clearly what the mountains look like and how steep the slopes are. It's all done with lines. But how do the lines help us to see the shape of the land? Let's find out. First, I'll draw a map. Let's say this is a map of an island, an imaginary one. I'm just finishing off the coastline. That's the sea, and all this is the land. Now, I want a mountain on my island. Right, there's a mountain. So now I've got a map of an island with the shape of a mountain on it. That's a funny sort of map. You can't really go around with shapes like this stuck all over a piece of paper. Look, you'd never be able to fold it up. I need a way of drawing the shape of the mountain onto the paper. The area's easy enough to do. I just draw right round it, like that. But I need to be able to show how high it is as well. Well, it's easy enough to work out the height from the bottom to the top. And I could put that height down on the map. But that still doesn't show you what shape it is. I need to be able to show that it's got steep sides. And this is how it's done. This mountain has got lines on it, and the lines that run right the way around are absolutely on the level. And the distance between each level is exactly the same. I've marked the levels 1, 2, 3, 4. That shows that it's getting higher. Now, let's look at this from above. If these lines were drawn onto my map, just as you're seeing them now, they would tell me that this mountain is round, that it has the same sort of slope on all sides, and that it comes to a pointed peak at the top. Lines like these are called contours. It's fairly easy to show what contour lines look like on a small model, but it's not quite so easy to do when you're faced with a real hill, like this one behind me. Now that's just a bit too big to take a ruler to. So I'll just have to think of another way of showing the contours on there. is the same hill seen from the air. Now, let's put all the contour lines on it. The contours tell you that this is a round hill with the same sort of slope on all sides. A contour map has numbers as well as lines. The numbers tell you the height of each contour. Of course, this hill's a very simple shape. In fact, it's man-made and was built thousands of years ago. But hills and mountains that were formed naturally often have quite complicated shapes. Yet even the most complicated shape can be shown by contour lines. This is a very rocky island. We've marked the contours on it so you can see them from the side and from above. On a map, this is how you'd see them, from above. And if this was a map, the heights of the contours would be marked on as well. Together, they'd tell us the land slopes up from the sea. In some parts of the island, the contours are wide apart. That means a fairly gradual slope like this. But where the contours are closer together, as they are on this side of the island, the slope is steeper. It's quite a cliff. The heights of the contours on a map have got to be measured from somewhere, and that place is sea level. So a number on a contour line tells you how many feet or meters it is above sea level. But contours don't just go up from sea level, they go down as well, and they tell us the shape of the land underneath the sea. Contours, of course, are only lines on a map, but if the contours on this island were really there, then each line would be on the level and at a particular height above or below sea level. So when you look at a map of an island like this, you can work out from the contours how much the land is sloping, how it twists and turns, and how high any point on the island is. Contour lines can be used to show the shape of almost any surface. Just think of all the different mounds, hollows and ridges in a face. You're looking at a model of my face. See how the contours bring out the shape of it. Here's Nose Peak. On one side there's a gradual slope, on the other a cliff. Contour maps help us to see the face of the Earth. This is a large-scale map of Beacon Hill. It's a hill near a village called Ivinghoe. Children from the local school were making a study of the hill. They'd marked out an area they were particularly interested in.
Look, that must be the beacon. Let's see if we can try and make a model of it. But we need to trace the contour lines first.
The children had found a way of using the contours on the map to make a model of the hill. They began by making a tracing of all the contours in the area they'd marked out. There were a lot of contour lines to copy, and it took them quite a time to do it. To make a really large model, their teacher found a way of making the tracing of the map much larger. The children then cut round the lowest contour line on their larger scale map. To make the model, they used thick sheets of corrugated cardboard, all the same thickness. They then copied the lowest level on the map onto one of the sheets of cardboard. Once the line was drawn, they cut round it. To help make the sheet of cardboard thicker, they stuck small cardboard spacers underneath. By doing the same with all the other contours, they were able to build the model up. Finally, they covered it with papier-mâché and painted it to make it look like the real thing. They certainly brought the map to life. Even the footpaths and roads were included. Because they knew the hill so well, they were able to get a very good likeness. They also referred to some aerial photographs. I decided to go and visit the real hill. I took a similar map to the one the children had used, so I could see for myself how steep the slopes were and what footpaths to take. Seems to be a footpath there. Let's have a look. Yes, that's the one I'm looking for. That was a hard climb. It's quite high up here, though. Do you know, I think that footpath is probably the steepest one I've ever walked up. But I should have been warned, because I looked at my map before I came up here. Here we are. You can see on the map that the contour lines are very close together. Now, that's always a sign of a steep slope. And here's the footpath that I took. You see, it leaves the road and goes right across the very steepest part of the slope and up to the top. The land across the road there looks pretty flat from up here. So let's see what's shown on the map there. Here are the contour lines, and this time they're very wide apart, and that means that the land is sloping gently. Contours, of course, show us how steep the land is, and also what shape it is. But there's only one way to find out what it's really like, and that's to get out and see it for yourself.